what we are planning to do for these few sessions is we are going to help you to orient yourself towards solving the problems. So we don't have the time to cover all the theory that you are supposed to learn from your textbook or any other teacher. But based on that theory, how do you start to approach the problem solving? That is the focus for our lectures. So for today, I'm going to discuss some physics problems. And the way I will do is the first half of the lecture, I will solve some problems. And in that process, I will try to illustrate how you are supposed to think about these questions. And then the second half, I will open it up for you to start trying to answer the questions. And let us see that based on the understanding that we are going to develop, are you able to make a fresh attempt to the problems? And then next Tuesday, when you will have the second physics session, so you will have 1 week's time in between, right, to keep trying these ideas. So ideally, if everybody understands the approach, maybe next session we will not have any doubts. Everybody would have solved everything. That would be the best case scenario. Okay. But let us see. Let us hope for the best and let us get started. So let me just share my screen. Okay. Can you confirm that you can see my screen?
Yes, we can see.
Okay. Okay. So yeah. So my name is Prashant. Maybe I've met some of you already before. I've decided to call this part solving physics. I've deliberately chosen the word solving physics because what we are going to do is try to solve physics problems, but understand that, understanding the physics concept is out of scope for such a short course. So that is something you have to do on your own. But how to start solving physics problem is what I want to talk about. And I honestly like how to understand the concepts of physics, which is a very beautiful thing on its own. I think I am not qualified to do that because I mean, if I just briefly talk about my background, that I have been a student of M. Prakash sir for a really long time. I studied at MPI at 2006 to 2008, and I appeared for JEE in 2008, and I cleared JEE during that year, and then afterwards I've been trained as an engineer and now working in the software. And in parallel, I also have experience with mathematics Olympiad for many years now. So, I mean, the question is, my background is from maths as such, but surprisingly, JEE 2008, right, when I appeared for the exam and I was the topper from Pune city, although my background is from mathematics, my physics score was more, around 1 out of 150 or so marks. I had almost 140 in physics. So maybe only one or two questions I got wrong. So surprisingly, my physics score was more than mathematics. And through what we are going to see today, that you will understand why. Actually, mathematics is the most important foundation on which your physics performance can be really good. So scoring physics is a different thing from understanding physics. So you should always try to do both in parallel. Okay. So basically, any problem that you want to solve in physics or any topic, there are some standard steps that you have to go through. What is the approach by which you solve the problem? So the first thing that we do is that typically the problem is presented like a word problem, right? Some information is given. So first thing you have to do is understand what are the variables involved in your situation, like what are the given variables, what are the variables that you have to compute, that are what are the unknown variables, and which are the important formulae that will allow us to go from the given information to the required information. You can almost think of this like, you're traveling from one place to another place. Maybe you're going from Pune to Mumbai or, from any one city to another city. So you have to find out the path that how should I proceed from where I'm right now, where can I go next? And after that, where can I go next? So like that, taking small steps at a time, you can start from any given information and reach the desired result. So that is the important step where we convert the information into equation. Once the all the information has become a mathematical equation, then the step two becomes just solving the equation. So step two is purely mathematics. So there you should know how to solve equations like linear equations, quadratic equations, simultaneous equation. So all that you can do in step two. So almost no physics is involved in the step two. But then step three is very important because after you solved the equation and you got the final answer, we need to interpret it back into the physics because sometimes that answer is the direct answer. Like maybe they ask the question that what is the mass of an object, and you get the value of that mass, and that is the answer. But sometimes you have to think logically that is the answer valid or invalid. Like for example, suppose you solve a quadratic equation and you will get a positive root and a negative root, right? But if that variable is the mass of an object, then we understand that the mass cannot be negative. So we have to take the positive root. So this kind of interpreting the mathematical solution back into the physics is very important. And I mean, if you don't do the step three, you may lose the marks. Like, even if you have solved everything correctly, you will not get the advantage. So pay attention to all these three steps. And then, so these things are common for all subjects, nothing particular about physics as such. But now coming to physics, that when you are going to solve a physics problem, what are some additional things that you should keep in mind? So first thing is that if there is a motion of any object involved, try to draw a rough diagram. So you know where the object is currently, where the object is going to be a few seconds later, and things like that. So the diagram is going to be a very important guide. Don't just start substituting values in the formula that you know without understanding the relative position of object. That is the object approaching the ground, going away from the ground, and so many things, right? So draw the diagram along with the forces. So like if an object is falling under gravity, then we have to show the force of gravity. If there is some other force that is mentioned, show all the forces, because finally, as we know from Newton's laws of motion, that the sum total of all the forces is going to determine the motion of that object. So keep that in mind. Uh, then one important thing whenever you're drawing the diagram, setting the variables, make sure you don't confuse the signs. Sometimes an object is moving in one direction, the force acting is in the opposite direction, and many such tricks are played in the way the question is set. So make sure you choose some direction as a positive axis and some other direction as a negative axis, and follow a uniform notation throughout your calculation. Okay, we'll see examples of this, like how you should carefully choose the sign. And similarly, don't get confused in units, because the question may deliberately give half of the information in one unit, like something will be in meters, something will be in the centimeters, gram and kilogram, and so on. So make sure to choose one system of units, maybe MKS system or CGS system, and use that system for the entire question. So any other information, convert it into that system first, and only then start the calculation. So, okay, so these are some basic things that you should keep in mind when you are going to solve any physics problem. Okay. So this is what you should supposed to do when solving a problem. But now you have to think about how to prepare. Like what is the background work, what is the homework you should do, which will help you to solve problems very well. So first thing, you should have very solid understanding of the concept. So the understanding of laws of motion, laws of various kinds of force like electric force, gravitational force, various conservation laws. So we have conservation of momentum, conservation of energy, and so on and so forth. So actually, I am going to cover only two or three topics today. So I'm listing examples of that here. But same thing will be true in other domains like electricity, optics, and heat, which we'll look at in the next week's lecture. But right now, this lecture, we are going to focus more on motion, force, and energy, those kind of topics. So along with the topics, you should also know the important formulae. You should have your own revision sheet ready where all the important formulae are nicely listed, which you can quickly revise. So what are the important formulae that you should know? Like what is the motion at a constant speed or constant acceleration, which we call kinematic equations, right? Then Newton's laws of motion. Then objects which are floating in a liquid, the what is the buoyant force, what is the density of an object. All of these are basic formulae which you should know, and you should be very well versed with that. Just to show an example of, I mean, if I were to prepare my own revision sheet, what would it look like? So I'll just show a screenshot of that. That this is the sheet which I have. So I created this Excel sheet in which I've written out all the formula. Like this is the equations of motion, this is the energy, this is the fluid mechanics, electricity, optics, everything. So this is how I've organized it. But important to say, I am not going to give this sheet directly to you. And the reason why I'm not going to give this is to you, that will be useless. If somebody gives you the ready reference, but you don't know how to read it, what is the use? It will be useful for you only when you write it in your own words. Because every person has a different way of thinking. Somebody may have to write like to write it in a table manner, somebody may like to draw diagrams, whatever it is. So choose the pattern which you are comfortable with, but in any way create your revision formula sheet so that you know all the important formulae. But that is only the first step. After that, you have to also be prepared for the exam, because every time applying the basic formula will take a lot of time. So you should use that information and create more specific data. Like specific cases, you should create a special formula for that. So for example, we are going to see cases like this happens all the time, right? You are given an object which is released from an altitude and it falls to the ground. So how much time it takes for the object to travel? So you can calculate this from the kinematic equation, but doing that every time, you will waste a lot of time doing the same calculation every time. But if you have the formula ready, you will save many precious seconds. And similarly, if an object is already moving and it comes to a halt because of a negative force, so actually, if you think about it, it is the same formula for the dropped object, just in the reverse direction. And similarly, formula for kinetic and potential energy based on how far it is from the ground, or what is the ratio of an object, like the submerged volume of an object if it is floating in a liquid. So these are standard things which are going to come again and again. So save your time by preparing this formula in advance. Okay. And this is going to be useful for you even when you actually appear for JEE, because there also time is very critical. And last but not the least, as I started my lecture by saying that mathematics is the most important foundation. That in the step two that we saw earlier, after you have converted everything into mathematical equations, you should not get stuck there. That now I have converted everything into mathematics, but I don't know how to solve the equation. So there you have to be very efficient in solving linear equation, quadratic equation. You should have multiple methods to solve quadratic equation. That you know how to factorize. Sometimes it is not easy to spot the factorization, so you know how to substitute the standard formula, that root b square minus 4ac, and how to solve simultaneous equations in multiple variables. These things you should know very well. That should not be the reason why you did not get the problem. Okay. Similarly, adding vectors should be easy to do. And in geometry, like knowing some standard area formulae, volume formulae, and simple concept, like if you double the size of an object, what happens to its area? What happens to its volume? Like double size object, the volume gets cubed, right? So 2 raised to 3, 8 times the volume changes. This basic intuition is going to be very important, and you will see examples of this in what we do today. So this is all the homework that you have to do before coming to the exam. And what I showed in the previous slide is what you're going to do during the exam. Okay. So we are going to start solving the problem soon, but just one last thing I want to show to you, because I think this is a very important concept. This is somewhat advanced topic called degrees of freedom, but I will try to simplify it for you and explain why this is going to be so important for you. So simply speaking, the definition of this concept is that how many independent parameters or quantities can you choose, that based on those quantities everything else can be computed. Okay, that is what we call degrees of freedom. So starting with a simple example, like everybody has done simple interest in school, and so you know the formula for simple interest, like PNR upon 100. So in that equation, think of the four variables that are involved. So just a minute. Okay, so can you see my tablet? I'm writing here. Okay, so this is the formula for simple interest, and so it involves four variables, right? The interest, principal, number of years, and the rate of interest. So if you think about it, out of these four quantities, if I give you any three quantities, can you find the fourth one? Yes, right? So which means that this system where we have, it has 3 degrees of freedom, because I require three out of these quantities to find out the remaining one. And I to this set I can also add amount, right? So actually, out of these five quantities, any three, if I'm given, I can find all the remaining quantities, right? So this is called a system of 3 degrees of freedom. And why is this important? Because sometimes you're given the information about some three objects. So like suppose you're given principal, number of years, and interest, and you're supposed to find amount. So now the question is, can you find this or not? So even before looking at the formula, just knowing that this is a system of 3 degrees, I know that if these three quantities are given, I can find this. And you have similar examples in mathematics everywhere, even in chemistry actually. So these degrees of freedom is a very important idea. So just to share an example from physics, like for example, take the example of motion under acceleration. Okay. So like the kinematic equation. So what are the variables that are involved? You have the initial velocity, which we denote by u, then v, which is the final velocity, then A is the rate of acceleration, then T is the amount of time for which the object is moving, and finally S is the displacement. Okay, and I think everybody must be knowing the equations. Like if for example, if I am given these three quantities, U, A, and T is given, can I find V? Yes. And similarly, all the equations, right? So what you will realize is that this is again a system of 3 degrees of freedom, because out of these 5 quantities, if any three are given, I can find all the remaining ones. Okay. So like that, your homework, like I'm going to give you few homework things to do. So the first homework is for you. Try to find as many different set of variables which are related by some formula, and try to determine its degrees of freedom for that set. Okay, so this is an open assignment that you can think of so many examples from mathematics, from physics, from many other topics also. So, like for example, you have done questions like profit loss, like cost price, sale price. Those things can also be thought of in this way. And in physics also, every topic, every formula has this concept of degrees of freedom. Okay, just to repeat, actually, this is a very advanced concept that you typically deal with after 12th standard. But I think this is a very useful idea, so that is why I'm just briefly talking about it today. That how you can think of every problem in terms of the degrees of freedom, because that tells you that what is the information given, based on that what can I calculate, and based on that again what can I calculate. So you can keep taking one step at a time in this way to reach whatever final answer that you want. Okay, so this was the idea of degrees of freedom. Okay. And so now, the way I thought that we can start to look at the questions. So we are going to look at two question papers, right? So we are going to look at January 2023 question paper and April question paper. So there are total 10 and 10, total 20 physics questions that I am going to discuss today and next Tuesday. So I looked at the question. I tried to categorize them in as per topic and subtopic, and based on those topics, we are going to start looking at the question. So as I said, today I am not going to cover all the topics. We are only going to cover motion and forces, uh, density and buoyancy, and heat and temperature. Sorry, energy and work. Okay. So these three topics I'm going to cover today. So we are going to do 5 questions of one paper, 5 questions of another paper. So total 10 questions we will do. Remaining topics like electricity, magnetism, optics, heat and temperature. All of this we will study next Tuesday. And my hope is that based on the way you understand that we do today's topic, you will come prepared for next week's lecture, that you will have already attempted the questions, hopefully solved all the questions. That would be the best case scenario. Okay. But so these are the topics which we need to cover today. So let us start with the very first question. Okay. So, yeah, January 2023, question 11. Okay, so I will read the question, and anybody who has already solved the question, just raise your hand. I will not ask you to solve it right now. As I said, first half I will only explain, but second half I will ask you to solve. Anybody who has already solved this question, please raise your hand. So I know that how many students already know how to solve the question. Okay, two students have raised the hand. Others, three, four. I do want to know, others, have you tried the question and could not get it, or you have not tried it at all? Okay, five, six, seven students are raising their hands. Okay, so let us see that we are going to start reading the question, and as and how we go along, we will try to think that what is expected to be done, what we should do first, what we should do next. So okay, so even if those who have not tried it, no problem, we'll try it together. Okay, just think of it like this is like an exam, but only difference is that in exam you will not get so much time to think and discuss. There you have to act quickly. But right now, because we are in the learning mode, we are going to take our time to understand every part of the sentence and start attempting it properly. So first thing it is given the large weather balloon is rising vertically at constant speed of 8 meters per second. So, and when it was a particular distance from the ground, a small object was released and it fell to the ground. And so, in your mind, now it should start playing that what is going to happen. So, that balloon was moving upwards, and at one point, a mass was released. So, as soon as the mass is released, you know what Newton's laws say that the mass will not immediately start falling to the ground. It will continue its motion along with the balloon, and after a while, because of gravity, its direction will change. Okay, so that picture should be clear in your mind. And then after the mass hits the ground, during that time frame the balloon will have climbed even further up because the balloon is continuing to climb, right? And so at that point, what is the distance of the balloon from the ground? That is what it is asked. Okay, so this, even before you write even a single line, the picture should be clear in your mind that okay, this is what it is going to be looking like. And now let us try to draw the diagram that what is it going to look like. So this is January 2023 question 11, right? So as I said, maybe the like the balloon looks like this, and at this moment it is rising up at 8 meter per second. Okay, so this is at the current moment, and you know the way I'm going to draw the diagram always is that the horizontal axis is my time axis. So right now, you know, the mass is also with the balloon, so the mass is also going up at 8 meter per second. Okay, so now let us say at this particular moment, and we can call it t equal to 0, the mass is released. So what will the trajectory of the mass look like? Will it immediately fall to the ground like this? No, right? As we said that for a moment, the for the instant that the mass is released, the mass still has the upward velocity of 8 meter per second. So most likely what the mass will do, it will rise for some time and then fall to the ground, right? So after a while, what will the picture look like? That the mass has fallen to the ground, and in that time frame, the balloon has climbed another some distance. We don't know how much distance. Okay. So at some other point of time, which we call t, uh, so this is time 0. I will not write t over here. So at time 0, this is the picture, and at time t, this is the picture. Okay. And so now, as I said that we have drawn the diagram, now we need to start understanding what are the variables that we care about. So first thing is the distance from the ground, right? Is it given to us, the distance? The distance is given, right? The distance is 132 meters. So this is 132 meters. Okay. And we know its upward velocity at this point. So now we have to start thinking that what are the formulae I know which will allow me to compute the path of this mass. So if you know the equations for kinematic equations, that motion under acceleration, that is what we have to use right now, because what we have right now is the initial velocity of the object. We know how much the object has moved, so this 132 meter we know. So based on that, we can try to find the time. Okay. So now the important tip which I mentioned earlier, that we have to choose the signs very carefully, because you know here some objects are moving upwards, some objects are moving downwards. If we choose the wrong sign, our calculation will go for a toss. So let us use this convention. We'll always consider upward direction as positive direction. So any distance that we move in the measure in the upward direction is positive, and downward direction is negative. Okay, so this is the convention we established. Now, based on this convention, let us start to write the equation. So, first, what is the initial velocity of the mass? It is plus 8 meter per second. And I am always going to, this entire question I am going to solve in the system where I am going to use meters and seconds. Okay. So all the information is going to be in terms of meters and seconds. So that is why I don't have to write the units every time. Okay. So the velocity is plus 8 meter per second initial velocity. Okay. Then how much is the displacement? Like how much does the object move? It moves 132 meters, but it moves downwards, right? So it will be mistake for me to write plus 132. The displacement is minus 132. Okay, time taken is t, right? That is t because that is the time for it was traveling. And then what you put on acceleration, because once the object is released, it will be influenced by only gravity, right? So the gravitational force will be. So now if you think about it, the question has given the mass of the object also. See, this will happen many times that the question will give you extra information which may mislead you into thinking that you know that information is required. But if you think about this question, the mass is not important. finally what matters is the acceleration. And so we know that under gravity, no matter what is the mass of the object, the acceleration is always going to be 10 meters per second square. And in this case, I have to choose it as minus 10, right? Why? Again, because acceleration is downwards. So here I have all this information. So T is unknown. But apart from T, so do you see that this, I know that this is a system of 3 degrees of freedom and I'm given 3 quantities. So I can find anything else that I require. So here, for example, I need to find time T. So now I have to start thinking that out of all the formula I know, which formula will allow me to compute the time based on this information. And so if you think about it, we know this equation, right? The second equation is ut plus half at square. S is equal to ut plus half at square. Does everybody know this equation? Now it is simply a matter of substitution, right? So you see at this point we completed step 1, that converting the data into mathematics. So now at this point this is just solving this equation to get the value of time t. So let us do that. So if I just substitute all the values, what am I going to get? So minus 132 is equal to 8t plus half 8 square. So now once you have converted everything into this, the only unknown variable is t, and this looks like a quadratic in t, right? So we can solve for this. We'll just simplify this. Minus 132 is equal to 8t minus 5t square. So we'll take everything to one side. So I'm going to rush to the solving part because I'm assuming you know how to do the mathematics. That is not what I'm here to teach you. What I'm here to teach you is how to convert the physics into mathematics and mathematics into physics. So now here I can try to factorize it, but I prefer that if the number is so large, maybe it is faster to just apply the formula. So I can write the formula t is equal to minus b, so that is plus 8 plus or minus root b square minus 4ac. So minus 4ac is plus 5 fours are 20. So 4 into 5 into 132. And by the way, here I'm writing it everything to explain to you. But when you're solving in the exam, you're supposed to do it very quickly. You should not waste the time writing so many intermediate steps. Remember that your mind travels faster than the hand. So do the calculation in your mind as much as possible. Only where you require to write it carefully, you take the time to write it. Okay. So this is going to be 64 plus 20 into 132. So that is 2640 upon 10. And so this is 2, how much is this? 2640 plus 64 is 2704. And again, if you know your perfect square, you know that. So this is looking at it, looks like just a little bit more than 2500, right? So this is going to be 50 plus something. So most likely this is going to be 52 square. And you can confirm that this is 52 square. So, and so your answer is 8 plus or minus 52 upon 10. And now the question is, so this is where the step 2 is ending. Should we take the positive sign or the negative sign? So logically, what do you think that this everything is happening in the future, right? So time t will be greater than 0, not negative. So we should choose the positive sign. But this is again homework for you to think. So homework 2, what is the meaning of the negative root? Okay. In other words, if I choose the minus sign, I will get t is equal to 8 minus 52 upon 10. That seems like nonsensical answer, right? How can time be negative? But mathematics is very clever. It is telling you something about the system which is very interesting. And so what is it telling you is your homework to figure out. For now, we are going to take the positive sign and finish the problem. So t is how much? T is 6, right? So in other words, for 6 seconds, the mass was falling. Okay. So now having understood that the time taken is 6 seconds, we should go back to the diagram and see now. Again, pause and look at the question. What is being asked? They are not asking the time for which the mass traveled. They are asking the balloon was how much away from the ground at that moment. So going back to the diagram, what we have to find is this distance, right? This is what they're calling capital D. And so how much is that going to be? This is going to be this height, which is 132, plus the extra height that the balloon traveled in 6 seconds. And can we find that? That should be just the speed of the balloon, that is 8 meters per second into 6, right? So that is simply going to be 8 into 6, that is 48. Okay. So therefore, the total distance that the balloon traveled is 180. And then again, because this is a numerical answer where the answer is going to be 00 to 99. So just to convert that 180 into that range, they have asked what is d upon 2. So the answer that you're supposed to write is d upon 2, which is 90. Okay, so I hope you understood all the steps, that what we did first, what we did next, and how you do it systematically, where you are very confident. You don't have to get confused that, will I get the right answer? Will I not get the right answer? See, if your strategy is clear, your confidence will be very good, and then you can focus on the calculation. Okay, if your strategy is only not sure, then you will, your concentration will get diverted. So that is why strategy is the most important thing, that we draw the clear diagram, establish the clear unknown variables, that what is given, what is asked, establish the right formula which is going to give me the answer, then solve the equation, finally get the answer, choose the right interpretation, that whether it is positive or negative, choose the right interpretation, again go back to the question, see what is being asked, and then calculate the final step. Okay, so this is the systematic approach which will work for every problem. Okay, if you internalize this thought process, no problem will be difficult for you. Okay, so this was the question 11. Okay, then moving on to question 12. By the way, some of the questions may have alternate solution also, but we won't have time to discuss all the solutions. As far as possible, I'm going to indicate the simplest approach, that what is easy for you to think in the exam time. That is my focus always. Okay. Okay. How about question 12 now? So again, I'll give 1 minute for everyone to read the question. Now again, think in your mind everything that we did for question, the previous question, how will you apply it for this question? Just think for 1 minute. Even those who have solved this question before, think about it in fresh terms. That just because you have solved it does not mean you have the clear idea in your mind. That do you have the clarity that what are you supposed to do at every step? So Kanak asked the question in chat in the previous question, that why is minus 132? Is the direction of displacement positive? So I hope it is clear that displacement is negative, right? Because any vector towards the ground we are considering as negative. Okay. Okay, so let us start to solve this question. Again, let us read the question. The block has 10 kg mass. There is a strong force. Wind force doesn't matter. It's a force. The nature of the force does not change the motion of the object, right? If it is a constant force, we know what is the motion going to be. Equal to half the weight of the block is acting towards east. So again, this is the way of giving indirect information. Instead of telling you that the force is of so and so magnitude, they have try to add one loop just to confuse some people, that they what is mean the half weight of the block. But again, clarity is very important. Everybody understand that mass and weight are not the same thing. Weight is a force, right? Weight is the force which gravity applies on the object. So if you know the mass of the object, you can compute the weight as simply the mass times the g, right? So based on that, we can know how much that force is going to be. Then at a certain point, the velocity of the block is given as some u, and it is at some point p. Now another force towards the opposite direction. So the velocity is towards east, and an opposing force is started to act on the block. And again, the magnitude of that force is given. And so after a point, that object came to a stop at some distance. Okay. So calculate the what is that u? That is what is given. Okay, so again, let us start by drawing the good diagram, that how do we represent this information in the diagram. So, let us say the object is over here, and I'm drawing the object like a block, but actually, if you think about it, the dimension of the object doesn't really matter. So, what they have said is at one point, the velocity of the block is u meters per second towards east. So, in our diagram, let us say this is east, this is west. So, at this point, let us say that time 0. At this point, the velocity of the block is u meters per second towards the east. And at this point, what are the forces acting on the block? Already there was one previous force, right? Uh, Acting towards east. So the force F1 acting towards east. And we know how much is the magnitude of the F1, because what is given? F1 is half the weight of the block. And how much is the weight of the block? The mass of the block into gravitational acceleration. And so here we know mass is given 10 kg. And so now this question we are going to do entirely in MKS system. Okay. So mass is 10 kg. Gravitational force is we know 10 meter per second square. And here actually the sign of gravity does not matter because motion is towards left and right. The G is only required to compute the weight of the object. Okay. So we know how much is the value of F1. And now there is one more force that we are saying that the second force is acting towards the west direction. We will call it F2. And let me just draw the force slightly larger because we know its magnitude is larger. Something like this. This is F2. And we know the magnitude of F2 also. Now again, we have to choose the sign very carefully. Which sign you choose positive, which sign you choose negative. So let us say that everything towards right is positive, everything towards left is negative. So what that means is that F2 sign has to be negative. Okay. So again, keep that in mind. So F2 is going to be minus 1.3 times the weight of the block. That is what is given, right? Going back to the question, magnitude of the force is 1.3 times the weight of the block. So we know the value of F2 also. So when two forces are acting on an object, how is the motion determined? By the sum of all the forces, right? So the total force, right, the F total acting on the object will be sum of F1 plus F2. And looking at the magnitude, it is clear that the total force will be in this direction, right? F total. Okay. So we can compute that total force. And so if the force is acting towards the left, but the velocity of the object is towards the right, what will happen? The object will start decelerating, right? So after a while, the diagram will look like this, that the object will come to a stop. Okay. So let us say the object has come to complete stop over here. So it has moved this much distance. And we are given that distance, right? We are given that the point Q is 4 meters away. So this was the point P, right? This is the point P and this is the point Q, and this distance is given to be 4 meters. So again, thinking back to the kinematic equation, what is the information that we have? What can we calculate? So we know the initial velocity u, right? The initial velocity is u, and that is a positive only in the right direction. Then when the object has come to complete stop, what is the final velocity? Zero, right? Then do we know the acceleration of the object? Because we know the force, right? So if we know the force, can we find the acceleration? Again, because force F is equal to ma. So I can find the acceleration as the total force upon the mass of the object. Okay. And by the way, notice that here I did not calculate F total. Do you know why I did not calculate? Because now if you see what is going to happen, there is a mass term here also, and now we are going to divide by the mass. So the mass is going to cancel away. So, don't waste your time multiplying and dividing again and again. If the term is going to cancel anyway, why are you bothering by multiplying it? So, these small time saving you can apply if you want to, do better in the exam. If you don't do it, you will still solve the question, but this will help you to solve the question faster. So, okay, keep these things in mind. Okay, so we know three quantities. We know the initial velocity, final velocity. We know and we know the displacement also, right? With displacement is plus 4 because in the so based on these three quantities, can we find u? Yes, right? Because again, this is a system with 3 degrees of freedom. So now all we have to do is choose the right equation. And so what is the equation which relates all these four quantities? I think you must be already knowing v square is equal to u square plus 2as. So in this, the only unknown variable is u. And so we can calculate that. So again, at this point, I hope that everybody is sure that the strategy is correct. Now, only thing left is calculation. Okay, so this is the most important milestone in any physics problem. Understanding the strategy and confidence that the strategy is correct. So now let us finish the calculation. So now let me substitute and find the value of A over here. So A was F total upon M, and F total itself is the sum of these two terms, right? So if I do the two steps together instead of doing it separately, so A will be F1 plus F2. So that is going to be 0.5 mg minus 1.3 mg upon M. So as I said, M will cancel. And so what you're going to get in numerator is minus 0.8 g. And g is 10. So this is going to be simply minus it. So minus 8 is the acceleration or deceleration of that object. And so in this equation, if you substitute everything, so you have to find u, right? So we'll keep u to one side, take everything else to the other side, and the final velocity is given to be 0, and the minus of minus 8, so will that will become plus, and so you are getting u square is equal to 64, right? And so then again, the same question as before, we are getting two solutions. You can be positive 8 or negative 8. What is the meaning of this negative 8 is the homework for you. So I'm going to call it homework 3. Then why are we getting these negative two roots every time? Is it just because mathematics doesn't understand physics? Or it is because mathematics understand more physics? So we will discuss this next time. But there's a very interesting reason why we get this negative root every time. But right now we are interested in the positive root. So we got a value of u as plus 8. And now going back to the question, yeah, we are supposed to find the value of u only, right? So we got the answer as plus 8. Okay, so again, I'll pause for a minute. Think about what you're learning from these examples, that how you're supposed to think, how you choose the variables, how you draw the diagram, how you choose the sign, how you choose the right equation, which will give us the final answer. All of these choices are very important. And as and how you're going to do harder questions in JEE, see, this is you are getting the answer in one step, right? Just by one formula, it is you are getting the answer. This is not going to be the case for harder questions. There you will have 3 steps, 4 steps. So there, seeing that direction, that which direction you are supposed to go, that vision is very important, and you should start developing it from these simple examples. Okay. So that was question 12. So as I said, we will do, so these were two questions on motion. Now question 13 is on fluids, density, buoyancy, those kind of concept. So again, read the question carefully. Think about the right variables, which are the important variables, which are the important equations about those variables, and then try to solve the question. Okay, so again, I'll pause for 1 minute. Okay, so what is given, that there is an object which is floating in a liquid, and so it is stationary. Most important thing is that it is a stable object, which means that all the forces acting on that are cancelling out. So any object like that, we know that there are two forces primarily. One is the gravity, which will pull the object down, and buoyancy, which will try to push the object upwards. And so if the object is stationary, it means that the two forces are exactly cancelling each other. And then the density of the liquid is given, and the most importantly, that line PQ is given, which is the level of the liquid, which means we know exactly how much of the object is submerged under the liquid and how much of it is above the liquid, because knowing how buoyancy works, the buoyancy is determined by the volume of the displaced liquid, right? So that is why that position of the line PQ is very important. Okay, and understand this is a solid metal cone. So this is a 3D object, but here we are looking at it from the front view, so it is looking like a triangle. But if I were to draw the same diagram in 3D, it may look something like this. I hope you understand that it is a 3D object. So actually it is like something like this. In fact, even though, because we cannot see the back surface, let me draw a dotted line. And somewhere around the half point, so the level of the water or the liquid is exactly at that half point. Okay, this is roughly the diagram which I will draw. And so, if you think about it, again, somebody just starts to attempt a question immediately without thinking carefully, they may get the answer, but they will waste a lot of time, because somebody will say, I'll compute this volume, I'll compute that volume. I'll compute the submerged part of the volume. I'll do a lot of calculations and get the answer. But just pause and think, is that really necessary? What is the minimum calculation required to solve this question? Because see, there is one important thing about that half point. See, if it was any point PQ, then maybe you have to do the calculation. But see what is given. This top height is 0.3 and the total height is 0.6. So if you think about it, it is like the top half is like a small version of the total cone, right? It's like a mini cone. It's the same shape but half size. Okay. Everybody is understanding this point that the part which is above the water or above the liquid is like a miniature version of the total, and the ratio is exactly 2 is to 1. So now the question is, if suppose I call the volume of this top cone as V, what will be the volume of the total cone? So total cone volume, how much will that be? So if the dimension doubles in every direction, uh, I hope everybody can see that the volume has to become 8 times. Okay, it is a cube. Just as area is proportional to the square of the ratio, volume is proportional to the cube of the ratio. Okay, so the total cube value will be 8 times V. Okay, so which means the total volume is 8V and the part above the water is V. So which means what is the submerged part? The part which is inside the liquid is 7V, right? This is the important thing, that without calculating any volume, we can just say that this submerged volume is 7V and the part above is V. Okay. So why is this important? Because this is going to help us finish the problem very quickly. Now, so the most important thing that we should know is what is the buoyant force, right? So if I write it as FB, okay, that is the buoy. I hope the spelling is correct. Buoyant force, as you may already know, it is equal to the weight of the displaced liquid, right? Weight of displaced liquid or fluid times, rather it is, yeah, it is equal to the weight of the displaced, right? Or in other words, if I had to convert into mass terms, it can be also written as the mass of the displaced fluid into G, the gravitational acceleration, right? So this is the buoyant force of the liquid will apply on that object. So like if I just show the forces in this diagram, I'll show it on the side because the diagram otherwise become too complicated. So like this is the cone and this is the buoyant force which is acting upwards. Okay, so we'll say it is a positive force, and the force due to gravity, right, which will act downwards. So Fg is the gravitational force, which is simply m, the mass of the object, times g, but I'll give it a negative sign because it is downward. And so if the object is at equilibrium, total force acting on the object has to be zero, right? And so that means the buoyant force and the gravity force are adding and becoming zero. Okay. So therefore, if the total force is zero, so then how will I relate the quantities? So what I can say is that the mass of the displaced fluid, so the mass of the displaced fluid times g has to be equal to the mass of the object times g. And then what will happen? The g will cancel from both sides. And so sorry, I made a mistake here. Yes, correct. So the mass of the displaced fluid is the same as the mass of the object. Now the only thing left to be found is what is the mass of the displaced fluid and what is the mass of the object. And we can do this in terms of density because we all know density is mass into volume, right? So because if you look at the question is not talking in terms of mass at all. The question is entirely in terms of density. The density of the liquid is given, the density of the object is asked. So we have to convert everything into density. So we can just replace mass by density into volume, right? So density of fluid into volume of displaced fluid. will be equal to the density of the object times the volume of the object. Okay. And just to explain, I'm writing it in full phrases, but we can use symbols to shorten the expression. But now the question is, in this equation there are four quantities. Do we know three out of them? If we know three, then we can find the fourth one, right? So going back to the diagram, we know the total volume of the object. The total volume was 8V, right? This is the total volume. Then we know submerged part is 7V, so we know that also. And finally, the density of the liquid is given. So I know three quantities. I only have to find the fourth one. So if I just substitute everything, so density of the fluid is given to be how much? That is 16 grams per cc. So 16 gram per cc times the volume of the displaced fluid, which was 7V. And the important thing is I don't know the value of capital V, but it is going to cancel anyway. So why did I bother? Why should I bother, trying to find a value? It is equal to density of the object, which you have to find out unknown object quantity and the total volume. So in this equation, V is going to cancel, and so the only unknown is small d, right? And so I'll get small d is equal to 16 into 7, 8, which is 14 grams per. Okay, understood this question. So again, just to repeat the step, what we did first, what we did next, and how this was a smart choice, that don't bother calculating the volume of the cone, small cone, big cone, when the only thing that matters is the ratio. So the ratio we can compute in terms of this 8V, 7V, and then we just have to say that the buoyant force is equal to the displaced fluid, and then these are the standard calculations. So one thing I'm going to suggest to you again, that I already showed this in the slide earlier, is that every question that we're doing, uh, go back to this point, the point 3 on this slide. We prepared with special cases of all the formula to save time. So, if you are prepared with those special formulae, you just have to substitute the values and directly get the answer. Okay. Like, for example, in this question, if you look at this, like, remember this formula. Whenever an object is floating, this formula is always applicable. The density of the fluid into the volume of the displaced fluid equal to density of object into volume of the object. If we knew this formula and directly applied it, you see we could have avoided all these calculations, like we found the buoyant force, we found the gravity force, we equated that. We don't have to do anything. So, if somebody knows this formula, their solution will be over in even less time and less calculation. So prepare these special formulae, and those will be your formulae. You are going to discover them. They are going to be useful for you. So don't expect somebody else to give it like a ready reckoner for you. That I'll just read this and go to the exam. That will not help. You have to work on this. You have to prepare your own formulae. Understood? Okay. So this was an example from buoyancy density. In the April paper also we have an example of a very similar kind, which we will do. So that will be in the second half today, where I will ask you to try and solve that question. Okay. So this was question 13. Now then we'll skip the in middle few questions because they are on a different topic, which we'll cover next Tuesday. I'll directly go to question 19. Okay, so question 19 again, read and take some time to think what is happening, what are the important variables, what are the important formulae, laws, everything. Okay, so Again, let us try to understand the situation, what is happening. The father is moving with a particular velocity along a straight line, and notice that the father's velocity is around 3 meter per second, and the daughter is traveling behind him, but at a higher speed, right? 6. So, which means that sooner or later the daughter is going to reach and she is going to catch and hold him, and after that they are going to move together. Okay. So whenever this kind of a situation is there, initially you are given some, and look at all the information given. It is a very tailor-made question for one particular topic. Because if you think about it, mass and velocity is given. Mass and velocity is given. So immediately your mind should travel to, okay, which concept has mass and velocity together? So what should come to your mind is momentum, right? Momentum is simply mass into velocity. And then when you think of momentum, you should also think of the fact that one very important property of momentum is conservation. That no matter how complicated interaction happens, the momentum of the total system does not change. Which means that initially the total momentum of the mass of the father and daughter together, and afterwards the momentum has to be identical. And in your mind you should start thinking that okay, that should give me some useful information. Whether or not it will solve the problem, I don't know, but that certainly looks like a useful idea. So I'm trying to motivate the train of thought that how you should start thinking about these questions. And by the way, just to mention that, you may think that, I came prepared for all of this before I have a lot of time to think. No, actually, I started to look at this question just 1 hour before today's meeting. So I did not open the paper until 6 p.m. So it is not that I had a lot of time to think and plan carefully. I did that deliberately, and I do that in all my lectures. I never go prepared with the problem beforehand, because that is not what the student is interested in. What the student wants is how do I think in real time, that when I'm reading the question, what are the thoughts coming to my mind? What should the thoughts coming to your mind be? So I'm trying to motivate that. So I'm trying to think aloud that when I read a question like this, what is the thought process in my mind? And that should be also what you should think about. Okay, so we understood that momentum is important for this question. And now again, we have to think about this diagram. So again, we'll draw a straight line. So the father is maybe over here. We know the velocity of the father, which is how much? 3 meter per second. And we know the mass, which is 70 kg. And the daughter is over here. Speed is 6 meter per second, and mass is 35 kg. So this is the initial. So what I'll say, this is the initial state of the system. Sorry, my pen is not writing properly. Initial state. Okay. This is how the system looks like right now. And after the daughter and father collide and then they start move together, and the position does not matter. See, one very important thing here, it is all about momentum, velocity. How far the daughter and the father is at any given point, that is not important. We are just caring about the total velocity of so now it is a daughter plus father system. Now there is only one object which is going to travel at some unknown velocity. We don't know the velocity of the object, so we'll just call it v, right? And but we know the total mass now, right? That is going to be 35 plus 70. So 105 kg mass and some unknown velocity. And so here itself, do you see that the way it is set up, even without writing a single formula, we should be confident that by applying conservation of momentum, I am going to get that velocity, whatever it is. So that I'm 100% sure at this point, I'm going to get that velocity. So now at this point, it is our choice that do we want to compute the velocity first and then solve the rest of the question, or we want to read the question first and then look at the velocity. So for now, let me find the velocity first. Okay. So let us do that. So in initial momentum, and in this diagram, everything is taken positive in the right direction. Has to be equal to the final momentum, right? So I just have to substitute. The initial momentum is first object. The father, what is the weight? 70 into 3. And again, everything is done in MK system. So I don't have to worry too much about units. Plus the daughter momentum, which is 35 into 6. This is the initial momentum, has to be equal to the final momentum, which is the total mass into the velocity. So if I just find the value of v over here, and I see that 35 will cancel nicely. So again, be smart, be efficient. Don't just start multiplying because you see multiplication. try to save your time by spotting that 35 is common. So let me get rid of that. And so I will get 6 plus 2, 6, 12 is equal to 35 threes are. So 12 is equal to 3V, which means that V is 4 meter per second. And so you see how we are going to get a nice answer. One thing I can say is that MPI takes a lot of care to ensure that the calculations are not difficult. We don't want to make have a situation where you are stuck because we have to calculate something for many decimal places. We try to avoid that, especially in physics. Sometimes in other topics you may have to do some calculations, but in physics we want your focus to be on the concept, not the calculation. So you are always going to get nice answer like this. In fact, if you don't get a nice answer, like if you start getting some crazy answer like root 47 plus 55, then you should become suspicious that maybe I made a calculation error. So, you expect the answer to be nice almost always. Okay. So the velocity got as 4 meter per second. So now with the system is completely determined, we know everything. And now coming to the question again, careful, don't write the velocity as the final answer. They have asked something completely different. They are asking the loss of kinetic energy. So loss of kinetic energy maybe is a very complex phrase, but if you break it down, it is a very simple thing that they're asking, that there was some kinetic energy originally, and after the collision, there is a different kinetic energy, and how much is the difference is what we have to find out. So again, knowing the formula for kinetic energy is half mv square. But this is for one object, right? So total initial kinetic energy will be the sum of the father's kinetic energy and the daughter's kinetic energy, right? So the father's kinetic energy will be the half into mass into 3 square. This is the father's kinetic energy, and daughter's kinetic energy will be the mass half into mass into 6 square. And then the final kinetic energy after the collision is going to be half into the total mass. So now total mass is now 105 into the velocity, which is 4 square. So all I have to do is now compute this. Let me, if I call this K1 and I call this K2, then the answer I'm expecting is K1 minus K2. Okay, so guys, I just have to calculate that. Okay, so let me do it quickly. Um, so again, I see that 35 is going to be common everywhere. So I will try to pull the 35 term outside instead of multiplying it every time. So I'll do everything. I'll just reduce this as 35 into 2. This is just this 35 will just go away, and this is 35 into 3. So that 35 I've taken common out from everywhere. So you see the first term is simply 9 plus uh 36, 18, right? So this is K1 minus K2 is 35 into 24, right? So this is going to be again keeping 35 common. This is 27 minus 24. So 35 into 3 is my capital E. And again, the value of this is more than 100, it is 105. So what they have asked is not E, they have asked E upon 5. So therefore, if this is E, then E upon 5 again, just 5 will cancel and you will get 21. So the answer is to be 21. So again, think carefully that, so this was a very different question in some sense, but because so far we have been talking about cases where displacement matters, time taken matters, but this is a question about the state of the system. The particular like details, that how much is the distance, how much time is not important. The initial state and the final state. Okay. So the change in the state does not change the momentum. So this question is very particularly testing your knowledge of conservation laws, conservation of momentum, conservation of energy. If you know those concepts very well, you can solve a question like this. Understood? Okay, so that was question 19. So now the last question of this paper. Again, I'll give you some time to think. So I hope you are getting the sense by looking at these solutions that maybe initially you thought that this was difficult, this is something that I've never studied, but that is not the case. These are things that you studied. Maybe you never thought to apply it in this way. But if your approach is systematic, you apply it correctly, you will do well in the exam. And this is true not only for this entrance test, it is true for every exam, including JEE. If your thought process is systematic, your strategy is clear, you have good techniques to save time, very important. You have good technique to save time, save calculation wherever possible, then you will do well. There is no secret formula apart from that. Is the time slightly ahead of like behind time, but it's okay. Okay. So in this question, seems like a lot of information is given because this is the last question of the physics part, right? The 10 questions of physics. So naturally, as the questions come to the end, they will try to make it more and more complicated. You have to be think more carefully, analyze the information. So it is expected to be a little bit more complex. But again, think about it that is it really complex? Can I simplify it in a way which makes it easier for me to solve the question? So let me read the question from the start that two cars are parked on the straight road where the distance between them is given and they start moving towards each other at the same time. This is a very important point. The motion of A is described and motion of B is described, but both process start at the same time. And now what is car A going to do? It is first going to accelerate for 5 seconds and then decelerate for 5 seconds. Again, accelerate for 5 seconds, decelerate for 5 seconds. So again, the cycle is 5 seconds. And during this time, what is B also doing? B is traveling towards A, again accelerating for 5 seconds with a different rate of acceleration. But the point is that again the cycle is of 5 second acceleration, 5 second deceleration. So in your mind is the picture clear that A, B are both accelerating during the same time frame and decelerating also during the same time frame. So they are perfectly in synchronization with each other. And then at some point they will meet and we have to find out after how many seconds they are going to meet. Okay. So again, there could be multiple ways to solve this question. Like one person can say, let me give a different set of variables to find how A is moving, different variables to say, find out how B is moving, and calculate and find out where they will intersect. You can do it that way, you will get the answer. But what I'm going to show is a faster way of doing that. Because what I'm going to say is, let us analyze the whole question from the perspective of A. Okay. Imagine that you are sitting in the car A and you are seeing what is happening. And then based on what you see, you can solve the question. Because what is the diagram going to be from? First, let us see what is the diagram from a outside observer. That somebody who is on the ground and observing the diagram, it may look something like this. That this is the starting position and A is accelerating, decelerating sometimes. Let us say that after 5 seconds acceleration and 5 second deceleration, A has reached here, and because B is has a higher traveling like acceleration, of course B is going to travel more distance. So maybe B is over here. So A has traveled this much, B has traveled this much, and in that somewhere in the midpoint was the point where like up to the first half A was accelerating, B was accelerating, and the second half A was decelerating, B was decelerating. So this is the picture from somebody who is sitting at the ground. And so here the rate of acceleration is 1 meter per second square, and here is 2 meter per second square. But now imagine sitting inside car A, what are you going to see? So because you know that relative velocity adds, like if you are traveling towards some person and that person is also coming to you, relative to you, you will see that the person is traveling even faster, right? So the velocities add that way. But not only velocity, even acceleration can be added that way. So important thing. So like velocity. So just as you have concept of relative velocity, you also have the concept of relative acceleration. Okay. This may seem like a little bit advanced concept, but it is completely intuitive, right? We are just adding the acceleration together. So what I'm saying is that why don't we analyze the problem as if sitting inside car A, B is traveling towards you not with 2 meter per second square, but 2 plus 1, 3 meter per second square. Okay, so I am suggesting the diagram is looking like this, that you are at A, you will always sit here, that you will always be stationary. So let me not draw it this way. But B is approaching you, so B is going to accelerate with a 1 plus 2 is equal to 3 meter per second square. Because why are we adding? Because they are both accelerating in the same direction. So that is why the just as velocities add, the acceleration can also be added. So what is the trajectory of B going to look like? That initially, let us say B starts over here. The distance, initial distance is 300 meters, right? So let us say for the first 5 seconds, B is going to accelerate towards us at 3 meter per second square. Okay. So can we compute how much is this distance? Like if I call this distance as S, the displacement, I can calculate that, right? Because what do I know? I know the initial velocity is zero. Like when we started, the velocity was zero. I know the time for which the bee is going to accelerate, that is given as 5 seconds. I know the rate of acceleration, that is 3 meter per second square. So again, this is a system of 3 degrees of freedom. I know 3 values, so I can find whatever I want. So can I find S as ut plus half at square is equal to, so this term will be simply 0. So this will be simply half into 3 into 80 square, so 5 square, right? So this is 75 by 2 meters. So S, the distance traveled by the car B in the first half, right, during the acceleration phase is 75 by 2 meters. And now we can find the same distance during deceleration phase, like as it decelerates and comes to a stop. So we can repeat the calculation, but one important principle in physics which I will emphasize is symmetry. Okay. What is the meaning of symmetry? It is like what goes up will come down. If you throw an object in the air and it travels for 2 seconds in the air and then it comes to a stop and then it will reverse direction and come back and hit the ground. So if it took 2 seconds to go up, won't it take 2 seconds to come down again? Because the situation is completely symmetric. It is like imagine you play a video recording of the object going up and you play the same recording in reverse direction. So it will look like the object is falling down, but the time taken will be the same. So in the same way, if you are accelerating for 5 seconds at some rate A and decelerating for 5 seconds at the same rate, won't you cover the same distance? And if anybody has any doubt, you can repeat the calculations and verify. But for now, I'm just going to skip that and use the symmetry argument to say that this part is 75 by 2 meters and this part is also 75 by 2 meters. So the total distance that the bee has traveled at the end of 10 seconds. So in 10 seconds, this is the picture that has emerged, that we started over here and now B has traveled 75 meters after 10 seconds. So you see, we have all the information now to finish the problem because we know that after every 10 seconds, B is going to repeat this cycle. So how many cycles will be required to cover 300 meters? It is clearly 300 by 75. And again, you see, note in JEE, they will try to become more tricky, that they will not give this a nice multiple. Here it is a nice multiple 4. So we know that 4 cycles are required to complete this, like 75, 75, 75, 75. In 4 cycles, we will reach A. And so the time taken is 10 seconds into 4, which is 40 seconds. So exactly at the end of the last deceleration, we will reach A. But if this same question was there for JEE, they will not give a nice answer. Maybe we will at the last cycle, what will happen? We will come very close to A, but we will not reach A. So for the last lap, again, we'll have to do slightly different calculation for the last few meters. But again, because we want to be nice for the question to be nice for the students, we are trying to give the nice number. So we have got the answer as 4 times this cycle will repeat and you'll get the answer as 40 seconds. So that was what is asked, right? What is the time in seconds after which they will meet. So again, important concept, two concepts I will say, which helps us to finish the question faster. It's not that you cannot do it without this concept, but ideally, this is how you should solve the question, that use the idea of relative acceleration so that you look at the question from the point of reference of A. So we call this concept called frame of reference. Okay. In other words, imagine what the situation looks like from one particular observer. So the observer is the driver of car A. And you can solve this question from the perspective of driver of car B also, but it will look the same, right? Whether A is traveling towards B or B is traveling towards A, the relative acceleration is 3 meter per second. So just the diagram will look from left to right instead of right to left, but the calculation will not change. Okay. So keep these points in mind that these are the important ideas and the question will not repeat. Whatever exam you are going to give, you will not get the same question, but you will get the same concept. And so you have to think and apply the concept accordingly. Okay. So now these were
Sir,
the, yes.
I have a doubt in this.
Okay.
Okay, so we use the concept of relative acceleration here.
Mm-hmm.
So, well, actually, the cars are moving towards each other, right? So, I mean, I didn't really get how the accelerations got added when they were in different directions.
So does velocity get added? Do you have any doubt in that? If one car is going from left to right at 30 kilometers per hour, another car is coming from right to left at 30 kilometers per hour, and they are traveling towards each other. So, from the perspective of one car, it will appear as if the second car is moving with 60 towards me, right?
Yeah, right,
It is
right,
just a illusion. It's not like the car is actually traveling at 60, but from my reference, it looks
right,
like that. So, just as
right.
velocity added, and acceleration is nothing but the rate of change of velocity, right? So, if velocity can be added, why not acceleration in the same?
Yeah, okay, got
Yeah.
it.
So
Thank
we
you.
are not at a position where we can write mathematical proof. Like we cannot write a proof the way we write a proof of Pythagoras theorem, but intuitively, I hope the picture is clear. Okay,
Uh,
so this
Thank
completes
you.
the
can you
anybody else?
explain
Yes.
why there is symmetry for the deacceleration?
Sure, sure, yeah. So, see, the best explanation I can say is what I said just now. That if I make a video recording, right, of the acceleration part, and I play the clip backwards, like if the rate of acceleration is the same, then the situation is exactly reversed. Like an object that is going from, let us say, I throw an object, okay, so it is going to travel upwards, and let us say it comes to a stop over here. So at this point, the initial velocity was, let us say, 12 meter per second. Final velocity is zero, and whatever is the g is constant. Now in the second half, you see now the initial velocity is zero and final velocity is 12. So all we have done is reverse the sign. If you look at the equation, where there was a positive sign, now there is a negative sign, but the time taken is going to be the same. So time taken here and time taken here is going to be same, because at every point, like if you just look at point by point, and at this point when the object was here, what was happening? The object was maybe moving upwards by 1 meter per second. At the exact moment here, the object will be moving downwards by 1 meter per second, but the situation is exactly mirror image of each other. Okay. So yeah, I understand. This takes some imagination to think about it, but if you do that, it will save time. Okay, so this completes the five questions which I wanted to share with you without asking your solution. But now let's come to the second five question from the April paper. And now this time I'm going to open it up for you. That okay, so don't unmute and start talking immediately, because we want to keep it systematic. Raise your hand. Anybody who has solved this question, I'll give you 5 minutes to think. Everybody try this question, solve it, and then raise your hand and tell me what is your approach. And again, focus should be on the strategy. I know everybody knows the calculation and the equation. What I want you to share is the strategy. Which variables you choose, which formula you apply. Yes, correct. We'll just wait for 2 more minutes so others can try. Anybody else who is able to solve this question? Or think of the idea. What is the important? Okay, Sarthak. Anybody else? Midaj. Okay. Okay. So slowly, I think people are getting the idea. Okay, so I think we can start to discuss. So Kanak, you want to share the what you are thinking about?
Yes, sir.
Now, who is speaking? I ask Kanak
Ye-
because I think she raised the hand first, right? Let me give her a chance. Kanak, you want to share?
So they have asked to find the particular distance in 5 seconds. So
Mm-hmm.
what we can do is the distance traveled in total 5 seconds minus the
Mm-hmm.
distance traveled in 4 seconds is what the distance traveled in fifth second. So
Yes.
in that way we can take u as variable,
Mm-hmm.
that is its initial velocity,
Yes.
and then we can apply the equation s is equals to ut plus half at square.
Right. Yes. Yeah, I think that is a very good way of explaining. Anybody else has a different idea or something similar to what Kanak said? Okay. I think mostly this is I mean, this question does not have a lot of variation. Anybody who has to solve the question has to do it this way only. So again, understand that what are the given variables, what is the unknown variable. So the diagram looks something like this, that the object is thrown upwards. The velocity of at which it is thrown is it given? Uh, it is not. It is given. It is simply said it is u meter per second. Okay, so the object is thrown upwards, and so the object will travel for some time, and then it will start falling. And one very important phrase given: the object fell. If it says the object rose, then the object is still traveling upwards because we don't know depending on the speed, right? After 5 seconds, the object may still continue to rise. But the important thing is given at the fifth second, already the object direction has reversed, which is important for us to note. Okay, so the object has already started to fall, and so maybe at time t is equal to 4, at the fourth moment, let me call it t1. So t1 is at the 4 second point, the object is over here and it is falling, and after at the fifth second, the object is somewhere else and it is still falling. And so what we know is this distance, right? This distance in that fifth second, and again note which is the fifth second, the one that starts at the fourth second and ends at second 5. Okay, so first second is when from t is equal to 0 to 1. Second is from 1 to 2, like that. Don't make the mistake of saying the fifth second is that t equal to 5 to 6. That will be the sixth second. Okay, just one like small point where somebody might make a mistake. So now all that is left is that up to this point, like how much is the distance? So if I call this first distance as S1, right? S1 is the distance that the object has traveled up to the 4 second, up to 4 seconds. And S2 is the distance that the object has traveled up to 5 seconds. And the difference between that is what is given to me, right? So if I just start writing the equation, so S1 will be equal to ut. And now as usual, I'm going to take the positive direction upwards, negative as downwards. So S1 is ut plus half at square. So that is u times t is 4 plus half minus t by minus 10 by minus 10 because gravity is downwards t square. So 16. Okay. So I got S1 as 4u, which is that 8, right? Minus 80. Is that correct? So this is S1. And similarly, can I find S2? S2 will be equal to u So maybe I should, for clarity, let me write T1 over here because T1 is the 4 second. And now H2 will use T2, right? T2 plus half A T2 square. So I'll have to put the value of 5. Right? So I'm going to get S2 is equal to 5 times U minus 125. Okay, so this is S1 and this is S2. And what is given to me is that the distance between S1 and S2 is 35 meters, right? 35 meters. Okay. So now be careful about the signs. In this case, because you have taken S2 as negative, so S1, so S2 plus 35 will be equal to S1. Understand why S2 plus 35 is equal to S1. Think of it in terms of vectors. See, S2 is this vector, right? S2 is this vector. And to that, if I add the vector of 35 meters, positive 35 plus 35, I am going to get S1. Okay. So if you think about it in terms of vectors, it will be clear why S2 plus 35 is S1. Okay. Don't make the mistake over there by choosing the wrong sign. And so now if I just substitute, the only unknown variable is U, right? So I can solve and get the answer. So let us try to do that. By the way, as I said, these are questions which I have never seen before. So we are at least the first paper I had seen 1 hour before the start of today's lecture. Second paper I am completely going blind. Like I have no idea what we are going to do. So it is completely in your hands now that you have to give the right idea to solve the questions. So okay, so can we solve this and get the value of U? So U will be I'm getting 2 as 10. Let me cross check if the answer is correct. And whether is that what is asked? Yeah, they asked find the value of U. Just a minute, let me check the answer key. Yes, the answer is 10. Okay, is this clear? Medaj, you want to say anything?
Sir, can you use the displacement in the n-second formula as considering
Yes.
u is negative?
Exactly, correct. So the suggestion for everybody is have this formula ready. Like if somebody does not know the formula, they can derive it from the basic equation. But if you have that formula, like find the displacement in the nth second. Okay. So everybody should think about having this formula ready, or a more general formula can be displacement from time t1 to t2, right? So t1 and t2 can be chosen anything you want because here it is given fifth second. A different question may be more complicated, like maybe from t equal to 4 to t equal to 7. So if you have this formula available, you can just plug the values and directly get the displacement. Okay, so use all of these tricks to save your time. Again, I am not going to spend the time deriving these formulae. You have to derive them, you have to document them in a way that you can quickly revise. If you do all of that, you will save time and hopefully solve more problems in less time. Okay, this was question 11. Then question 12. Again, I'll give you some time to think. If you get the question, you can raise your hand. Okay, anybody who has solved the question? Anahita, okay. Okay, so Anahita, you want to explain?
Just got some start is what I feel. So I would like to tell that.
Sure,
So it's told that a force of 1 Newton is applied in a horizontal direction on a block of mass 1 kg, which is kept on a frictionless horizontal surface. So it's
Mhm.
kept, so it's not in motion, so it's stationary initially.
Mhm.
So let's say that there's a horizontal surface and a block is kept, and
Mhm.
the force is acting in the eastward direction.
Mhm.
And we'll consider that direction is positive. So that force will be plus 1 Newton. So
Okay.
F1 is plus 1 Newton.
Yes.
Mass is given to be 1 kg, and we know that
Mhm.
force is mass into acceleration. So acceleration for the block for a time t seconds will be 1 meter per second square, positive.
Yes. Again, Anahita, what I want to focus is
Mhm.
the values are not important. What is important is
Okay.
we can find the acceleration, right? So
Right.
you can
Yeah.
express in that way.
Exactly.
Yeah.
Okay. So again, for next t seconds, there is no force applied on that object. So
Okay,
as
but before
it's
that, sorry, just to pause. So for the first 3 seconds, can we find out how much distance the object has traveled? The answer will be in terms of t because t is unknown,
yeah,
but we can find the
yeah,
expression, right?
yes.
Okay, okay, continue.
Okay, so for next t seconds, as there is no force applied, but it's a frictionless surface. So I think the force will continue to be applied and the acceleration will continue is what I feel. I may be wrong at this part,
No, no. So
but
yeah, what Newton's first law says is that if there is no force, there will be no acceleration. But whatever velocity the object has picked up, the object will continue to travel at that velocity, right? Without any acceleration. So at that point is simply our distance equal to speed into time formula with no
right, and
acceleration.
we'll be able to calculate velocity
Yes.
attained by that also in
Yes.
terms of
Correct.
t.
Correct.
And then next we will have the force as minus 1 Newton because it's acting in the
Yes.
opposite direction. We'll be
Correct.
able to calculate the distance and then we'll be able to put it in the given
Yes.
formula that 3t
Correct.
can
So
travel to
finally
1
we'll get
meter.
an equation that the sum total of these three distances is equal to 200 and t is the only unknown
Right.
variable. So we can solve and
Yeah.
get the value of t. Right?
Yes.
So everybody, I mean the calculation will come to, but first thing, even before writing in one single line, how you solve the question in your mind, isn't that amazing? You don't have to write anything, but you are 100% confident that if we follow this strategy, everybody will get the answer. So my question is why should I even discuss this question now? But just for making sure that everybody is on the right on the same page, I'm going to discuss the question. But at this point, I feel that everybody should be confident that in this way there are three stages, right? First stage, second stage, third stage. In each stage, I can find out how much distance the object has traveled. If I add all of them, I have to get 200 meters, and then I have to solve for the variable t. That is all that is there. So let us start to now apply this strategy. So again, for clarity, let us draw the diagram, like the first diagram, the object is kept over here, it is stationary. Then after the first phase, like phase one, this can almost think like a rocket launch. Well, you know how rocket launch happens. It has to be done in phases. They don't keep the rocket burning all the time. They burn it for some time, they switch it off. So when they switch it off, does the rocket suddenly crash to the ground? No, it keeps going with the momentum, right? So it is something like that. That for first phase of the motion, it is traveling, so we know what is the so again the information is not given in terms of acceleration, but it is given in terms of force. But we know how to convert from force to acceleration, right? So the force of 1 Newton is given, and so now in this case, I agree, Anita. Let us instead of writing variables, because everything is given so nice. It is mass is 1 kg, force is 1 Newton. So let us directly write acceleration as 1 meter per second square. So acceleration is 1 meter per second square for the first phase, and that phase lasts for t seconds, right? So how will I write that? Let me write it at the side. So here time is 0, Then at time t, this is the picture, and this is the distance. Let me call it d1. So d1 is the first part, phase 1, right? And at this point, the object has also picked up some velocity v, right? So let us calculate how much is d1 and how much is v. So which formula you want to apply? So initial velocity is 0. We know the acceleration is 1 and the time is the unknown. So we'll just call it t. But in terms of these three, can we find the v? And okay, because we typically use the letter s for displacement, let me call it s1. So can we find the velocity and the s1? So we just have to apply the formula, right? So s1 is ut plus half at square. Again, in your mind, don't even bother to write the term ut, because if u is 0, that is simply half at square. Okay, and so here it will be half t square by 2, because a is 1. So this was the s1. Then how much is the velocity going to be? It's simply u plus at. Again, u plus at, u is 0, so it is simply going to be at. So that is equal to t. Okay, one small point to make here, when I want to write v is equal to t, understand that here I'm ignoring the units. Technically speaking, t is in seconds and v is in meter per second. So it is not the time is the same as velocity, but keeping the unit part aside, the magnitude is the same, is what we are saying. Okay, so just don't look at the equation v equal to t and get confused that how are you equating time with velocity. We are only comparing the values. Okay. Or you can imagine that there is a hidden term of 1 like meter per second over here, but we are just being lazy and not writing it every time, but it is there. So this was the phase 1. Now what will happen in phase 2? So at phase 2 there is no force acting. So object will continue to travel at v, and for how much time? It is for t seconds. So now this was at time t. So now after additional t seconds, we are now looking at a time 2t. So imagine that this is like a series of photos that you are taking, right? No. So at time 2t, the object will have moved somewhere over here. And so now this distance s2, that is simply distance equal to speed into time. There is no acceleration, nothing. So I can directly write s2 is the velocity, which we already found here, into the time taken, which is t, right? So velocity, so this is going to be t square. Again, don't get confused that how is t square equal to distance. This is just magnitude we are comparing. So for S2 distance, it was just traveling without, and during this time, did the velocity change? No, right? Velocity will remain constant. So at the end of this phase 2, velocity is still v. And that is important because now when phase 3 starts, we are going to start decelerating the object. So and now the final phase lasts for another t seconds. So now up to time 3t. So now the object is going to start decelerating and come to a stop, right? And we have to find that. Okay, actually we don't know whether it stops or not, but we are just saying that it is going to travel for t seconds. So we don't know whether it stops or not. We don't need to know also actually. But what we're interested in this S3, this thing. So in during this S3 time, again there is a force acting on the object. How much is the force? If I just draw the object here temporarily, it is firstly in the opposite direction, and it is again given of 1 Newton. So force is of 1 Newton, which means acceleration is also going to be 1 meter per second square, but negative, right? Because now it is in the opposite direction. So our convention is we are taking positive in the right direction, negative in the left direction. So can we compute S3 now? That how much displacement will that be? Yes, Adiraj?
Sir, can we use the principle of symmetry?
Yes, very good point. We can use the principle of symmetry. Very well spotted. Because if you see what is happening in phase 1, the object is accelerating with the force of 1 Newton. In the last phase, the object is decelerating with the force of 1 Newton. Like temper, if you just forget the middle phase, isn't it the same question as before? Like you throw an object and it comes back. So it is a similar situation, I feel. Okay. So again, one point I have to make that sometimes we are making this kind of a assumption that this is a symmetry, this is a relative addition of velocities. Uh, this is precisely why I'm not calling my course concepts of physics or understanding physics, because all of these are concepts of physics which I don't have time to explain. But these are all very important questions you should ask your physics teacher, whoever that may be. That why is relative velocity, why is relative acceleration, how can it be added? Why does symmetry work in this way? Why does energy, momentum get conserved? These are all questions which come in concepts of physics, but to solve the question, you don't necessarily require all the concept. Okay, so that is why we are able to make progress. So therefore, yeah, we can directly say S3 is equal to S1, which is
Sir,
t square by 2. Yes,
won't the object have some initial velocity at the start of the third phase, while in the
it will
first
have
phase it did not have?
it will have initial velocity, but because the sign is reversed, right? See, previously what was happening, the velocity was getting picked up in the right direction and force was also in the right direction. Now velocity is towards right, but your force is towards the left.
Yes, but it did not have any initial velocity at the start of the first phase, so how can it be symmetric?
So what I feel will happen at the end of the third phase also, the object will come to a complete stop. That is what I think. And can we verify that? We can just plug in the values and check, right? So initial velocity at the start of the last phase is v. So how much, again, actually that same variable v is coming, but let us for now ignore it. So final velocity at the end of the third phase will be u, that is v plus at, right? And here a is -1 and v was t, right? V was t. So you see the final velocity is actually 0. So actually the third phase is exactly the mirror image of the first phase, right? So in fact, if anybody has any doubt that how the third phase is a reverse situation of the first phase, this makes it even clearer that at the end of this journey, the object will come to a complete stop. So we have found all the three parts S1, S2, S3. We just have to add them. So we are going to get S1, which is t square by 2, S2, which was t square, and S3, which is again t square by 2. So the sum total of all this, which is
Excuse
going to
me,
be,
sir.
yes,
So the acceleration of the S3 will be minus in negative because the direction is opposite.
it is negative, correct, correct. So in this equation, what is going to happen? -1 into t and v is positive, right? So you are getting t plus -1 t, which is 0. So isn't everything matching? Sorry, I'm not able to hear you. But I hope this part is clear. Now we just have to add the displacement. I'm about to get one equation. 2t square is equal to 300. And so, is that correct? Yes. So t square is equal to 150. And what is asked finally? Uh, oh, sorry, not 300, 200. See, you see how I was alert. If I were t square equal to 150, then t is coming a imperfect root of some number, and I was not expecting that. I was expecting a nice answer because finally you have to write 00 to 99, so it has to be an integer, right? So t square is 100, and again the question is why is t can t be -10? So again homework for you. Can t be -10? If yes, what does that mean? Like in physics, what is mean to travel in negative time? Are we talking about time travel, like traveling to the past? What is happening? There is something that mathematics is telling us over here. So if you're a close observer of the situation, you will see that there is something very interesting that the maths is telling. But anyway, so this was question 12. Let us go to next question, question 13. Again, so again, this is a question on density, buoyancy. Uh, I'm very interested to know how you approach this question. Anybody has any ideas how to start thinking about this question? Yes, Aman.
Sir, I think in this question we can use the formula where we equate the weight of the whole system to the buoyant force.
Yes,
Yes.
exactly. Correct.
Like we are getting the mass of the whole object, where we are getting the mass from the densities and the volume that is given in the question.
Mhm.
And on the opposite side, where the buoyant force is placed, we can calculate the density of the liquid is given. But
Mhm.
for the volume, we can take that as like the volume of the wooden cube, wooden block, and
Mhm.
plus that the volume of the metal cube. But in the metal cube, we have to subtract the portion remaining in the height. So like we
Mhm.
are taking the volume of the metal cube, but subtracting the remaining height from its height. So by calculating this, we can get the answer.
Okay, yes, I think the overall approach is correct. Let me describe it in a different way. Like, let us see what will happen to the system actually. Because starting, we have the only wooden cube which is floating because we know wood is lighter, so it will float. And now, when you place the metal cube, think in terms of forces what is happening. As soon as you place the metal cube, now the total weight of the system is the wooden cube plus metal cube, and that weight is not going to change, right? So, because of that weight, and that weight is more than the buoyant force acting on just the wooden cube, that is why the system starts to sink. So it will sink up to the point where the buoyant force is equal and enough to cancel the gravity. At that point, the system will stop to sink. So we just have to find that point. At what point enough part of the metal will have been submerged in the water so that the total volume of the combined group is enough to give the required buoyant force. That is what we have to find out. Okay, so this is the like logical understanding of what we want to do. Now let us try to draw the diagram. Like, at that particular point, when the system has come in equilibrium, that it is neither rising nor sinking, what is the system going to look like? So the wooden cube is of size 40 cross 40. So 40 cross 40. These are centimeters. This is the wooden cube. And on top of that, there's a metal cube of 20 cross 20, right? So this metal of 20 cross 20. Let me not write W and M, like it is understood. Okay, so this is the metal cube and this is the wooden. And the water level is somewhere, we don't know where the water level is, right? So I'm just going to draw a line. And what we have to precisely find out is how much of the metal is above the water level. Okay. So, but for me, I feel it is convenient to choose this part as my variable, because if I choose this as the variable, it makes it easier to compute the volume of the submerged part, right? Which I am interested in. So I'm going to call this part x, and then this we can always compute as 20 minus x. So I'm going to focus on calculating x. Okay. And now going back to and every time you not draw the diagram, equate the gravity force, buoyant force, we understand this principle and directly apply it, that the buoyant force has to be equal to, because the system is in equilibrium, the magnitude of the buoyant force has to be equal to the weight of the system, weight of the object, or in this case, it say combined total objects. Okay, so this equation should give me what I want to find out. So out of this now, which part I know, which part I don't know. So let us say the right hand side, weight of the object. Can I find the weight of the object? Yes, because all the information is given, right? I know the density of both the blocks. So I just had to compute the mass into the gravitational force. So let me first find the weight. So weight of two blocks combined will be equal to the gravity term multiplied by the masses. So the what will the mass of the wooden block? Wooden block is given of density 0.5 gram per cc, and wood metal block is given of the density 4.5 gram per cc. So I just have to, so volume, so 40 cube, 40 cube is the volume of the wooden block into 0.5 gram per cc plus 20 cube into 4.5. Okay. So this is the total weight of the two blocks combined. And in the stable situation, I expect this to be equal to the buoyant force. So we can calculate and simplify this, but before that, let us find the buoyant force, right? So the F buoyant, let us write it as F underscore B, like FB. FB is the buoyant force that will be equal to the weight of displaced fluid, right? And how much will the weight be? It will be because we know the density of the fluid also, right? That is also given. So density is very conveniently given 1 gram per cc, right? So the weight will be simply uh, again g times the mass of the displaced, right? And the mass is nothing but density into volume, right? So density of fluid into volume of displaced fluid. So now to calculate this volume, again we just did a little bit of geometry. We just had to find out the total combined volume of the wooden block plus this part, right? But that is not difficult to find. I mean, the wooden block is completely submerged, so that term will come as it is, right? So this is going to be G into density is simply 1 gram per cc, and the volume will be the volume of the wooden block, which is again 40 cube, just 40, sorry. Now, what will the volume of the metal block which is submerged? So the cross section area of the metal block is 20 cross 20, right? So the part which is submerged is like a cuboid, right? Of length and breadth is 20 and height is x, this unknown x that we are talking. So if I just draw that diagram separately, so the submerged part looks like this. It is a 20 cross 20 cross x dimension cuboid. So what is the volume going to be? The product of all. So 40x, right? No, so not 40, 20 into 20 into x. So rather you can say 20 square into x. So this is the buoyant force. And so this term, the weight of the two blocks should be equal to the buoyant force. And I can equate the two, and the only unknown variable is x. So I can solve and get the answer, right? So let us do that. And very first thing that will happen is g will cancel. So I will not even bother to write g. So I can write 40 cube into 0.5 plus 20 cube into 4.5 is equal to, again 1 I can ignore, I just have to write 40 cube plus 20 square into x. Okay, so I just have to solve for x now. So I just keep this to one side, take everything to the other side. And so this is 0.5, this is 1, so this will be minus 40 into 0.5 plus 20 cube into 4.5. Let me just check the calculation. I mean, if we get x as negative, then that is a problem. I don't know right now. Here, I'm a bit afraid that, see, 40 cube is such a big number. So is this going to be a very large negative number? And this number has to be sufficiently large to counter that only. Then I will get a positive answer. So let me just think once before I proceed with the calculation. But see how I'm proceeding cautiously. I'm not rushing to calculate, because if I calculate, I get a negative answer, I will have wasted my time. So this is how, students should think in the exam, that pause for 1 minute, just go back, check once. If everything is looking okay, then proceed with the calculation. But don't jump into it without giving it another thought, that have I made some substitution mistake, anything like that. So I think everything looks correct. So the weight of the first block is this much, correct. Weight of second block is the volume into density. This is also correct. So total weight is correct. Then this part, displaced fluid, the mass will be density into volume. Volume will be the volume of the wooden block plus the cuboid. So yeah, everything looks correct to me. I'm still a little bit doubtful. What if we get a negative answer? But let us give it a try anyway. Anybody who has completed this calculation already? Like, can you give me confidence that we'll get a positive
Yes,
answer?
sir. Yes,
Yes,
sir.
it's correct.
Okay, very good. Thank you. Okay, so I mean, uh, yeah, actually we can cancel this 20 square, right? We should not have to multiply and divide again and again. Let us just cancel that 20 square, and maybe that will help us. So if I cancel 20 square, these two terms will go away and become 2, and these two terms will go away. So I'll directly get x is equal to minus 4 into 40 into 0.5 plus 20 into 4.5, right? Okay. This will be, I can observe the 0.5 over here. This is simply minus 4 into 20 plus 2 into 45. This is minus 15. It's just coming positive, very on the edge, right? So I'm getting x is 10 centimeters. So if x is 10 centimeters, so which means that exactly 10 centimeters are below the water, and so 10 will be above the water. So very nicely, exactly half of the block had to be submerged to get this answer. So the answer will be 20 minus 10 is equal to 10. Okay, let me again just cross check the answer in the answer key. Yes, it is 10, correct. Okay, understood this question. So we are almost out of time. So the other two questions, question 19 and 20 are pending. Let me do that next time. I don't want to rush it just because, we want to finish something. But now certainly I observe, our speed has increased. Initially, we were going through some basics, so we had to take time. We had to be, slow and methodical. But now I feel confident that we can accelerate next time and finish the remaining two questions. But so last thing before I want to, end today's session, like just to give a list of homework or tasks that you should do, like things for you to do to come prepared for the next lecture. So these are the things which you should try to do. Yes, Sumit?
How did the volume become negative?
No, it did not, right? It remained positive.
40.
Which step are you referring to? Can you tell me? See,
20.
here it became negative because while solving, I had to keep x on one side. So I took this term to the other side. So it became minus 40, right? Minus 40 cube. So minus 40 cube plus 40 cube into 0.5. Okay. So again, I'm not focusing on the calculation part. I think if you spend enough time, you'll get it right. Okay, so these are the things for your task for you. Okay, that try to do this as preparation for them. So first thing, as I said, think about, try to list various systems of variables and formulae, like how various quantities are related to each other in every topic, every subtopic, and their degree of freedom. That how many variables you require to know, based on which you can compute everything else. So this degree of freedom is very important. So try to come up with as big a list as you can. This is the first task for you. Second task is, of course, try to solve the questions, like the remaining questions. So the remaining questions, like the two questions which we are pending from today, and the remaining topics, just to indicate what are the topics which the remaining questions are about. So like electricity, electric circuits, all that is there. There is a question on optics, like mirror, convex lens, and there are some questions on heat, like specific heat, latency of water and all that. So yeah, these are the topics. So do this for both the topics we did today and the topics we expect next time. Because if you do this preparation, you will be in a much better position to do the questions next time. So these are the two most important things you should do. And third is somewhat optional challenge, but those who want to know, you want to become good at not just solving problem, but you want to become good at physics. You want to become a champion of physics. You should answer all those homework questions. That what about the other route? Can somebody answer this question for me? Next time I'll be very interested to know what is that negative root doing? Where are we getting minus t, my negative values? All that I want to know. But okay, Dhruv, if you're going to answer that right now, I'm not interested to know immediately. I want everybody to think about this. But next time, definitely, I would like you to try and answer this. Okay, so these are the things that I would like you to do. Okay, so the next session will be on Thursday. I mean, it will be a math session, right? As per the schedule. So
Like chemistry.
chemistry. Okay,
Yeah.
okay, so chemistry for you. Okay, so all the best, and we'll meet again with Sohani
Yeah,
madam.
just a couple of minutes. Chemistry also, we are going to discuss two papers. January 2023 and April 2023. I will also display the questions like Prashant sir did on the screen, but if you would want a printout of the same, you can keep the printouts ready with you. Another thing, what I would want to do is, I would like to bring your attention to similar questions from earlier papers also. So if we discuss one particular question on one particular concept, in chemistry there is no calculation, so we will not take so much time. We will quickly revise the theory. As Prashant sir rightly said, it is not possible to go into the depths of the theory, but we can refer to the theory, understand the highlights of that theory, and then discussing the question is not as long as in physics or maths. So I would like to take your attention to similar questions asked on the same theory from our earlier papers. With that in mind, if you would like to keep a printout of all the papers till now, at least the last 4 or 5 years papers, then whenever I tell you that go to question number 3 of 2021, you will be able to spot that question very quickly. Those who would want to do it, just take a printout of all the chemistry papers, chemistry sections of our past papers. They are there on the website. Okay. So we meet on Thursday, sharp 7 we start. We will open the meeting at 6:45. Everyone should log in latest by 6:55 with their names on with which they have registered with us, and kindly ensure that you can keep your cameras on throughout. If you have some trouble with your cameras, try to get it fixed in the next 2 days. Okay, that's it.
Okay, thank you for joining. Bye.
Yeah.
Thank you, sir. Bye, sir.
Bye.
Thank you, sir. Bye.